All right, so this week, online office hours this afternoon from 1 to 2, and then I'll be on campus at North Harris. And for tomorrow, Wednesday, from 4 to 6, and Thursday, 9 to 11. And so remember that my office number is Winship 115K. And so come by Winship 115 to look for me. And if I have enough students who come by, then I may move around the corner to a bigger room. But there's a staff assistant there, and they'll tell you where I am, and there'll be notes and everything. So that's not a big deal. So just come to Winship 115 to find me. Tomorrow afternoon from 4 to 6, Thursday from 9 to 11. And I'll be happy to help you out during those hours. And, we can get on a real whiteboard and actually work problems and talk about the exam review. The exam 1 window opens Thursday, the 28th of this week, and runs through next Tuesday. So that means that you can take the exam anytime from Thursday to Tuesday. So Thursday, Friday, Saturday. I think all the testing centers are closed on Sundays, but then on Monday and Tuesday. So you have a five-day window where you can take the exam. And you go to any testing center in the Lone Star system, bring a student ID with you, or if you don't have an ID, bring a photo ID like a driver's license or something like that. You do need a photo ID to take the test. And so I'll write here photo ID required. And there's no calculators on the exam. So remember that. Remember that I've talked about this in lecture during the semester, that I understand that you have no calculator on the test, and I'm not testing you over arithmetic, and so I am not going out of my way to make the arithmetic horrible on the test at all. So don't, on WebAssign sometimes you had problems where the numbers got really, really big, and that is not going to happen on the exam. So I want to make sure you understand that. The test is also paper and pencil test, so it'll be a very traditional math test, and you'll show all of your work and kind of box your answers and everything. And I do request that what you turn in is dark enough. Some students kind of write really lightly with a pencil, so it needs to be dark enough so that when they scan that test, that the scanned copy is something that I can read. So just make sure that you're kind of thinking about that, and I'll put a note on the test to that effect also. Trying to think of anything else that I've got to mention to you about the exam. Does anybody have any questions about how, just the setup of the exam and all that kind of stuff, just the logistical aspects of the way this is going to work? Any questions at all about any of that? Okay, I heard one no out there, and I did get a question from by chat about how many questions are in the test, and I would say, to be honest with you, the exam's not quite done yet as far as me writing it, but it's a test that you don't worry about how many problems there are on it, because if I tell you there's too few, then people are going to panic. If I tell you there's too many, people are going to panic. So it'll be the length of the test will be such that you ought to be able to finish it in an hour and 15 to an hour and 30 minutes. I would allow 2 hours to take the test just to be on the safe side. So arrive at a testing center with at least 2 hours left on their schedule. So if they close at 8 o'clock in the evening, make sure you get there by 6. If you go on a Saturday afternoon, and the hours of the testing center you're going to are from 9 to 1, make sure you get there by 11 so that you allow yourself at least 2 hours to take the test. you should be able to finish it in well under 2 hours, but that will give you enough time that if you get into trouble on a problem or something, that you have some time to work on it a little bit. Anybody else have a question that they want to ask about? Anything about how the test is going to work or any of that stuff? We're okay?
I'm good. Yes.
Michelle, I can always count on you answering questions. That's good. I'm glad that you're always showing up because I need people to talk, and so I can always count on you. That's good. I'm happy about that. All right. So, and I understand some of you are probably in a position where you're in a room or in a workplace where you really can't talk out loud. So I understand that also. So, all right. Then today, what we're going to do, are there any math questions before I get started? Anybody have any math questions?
I do, but I'm going to wait till the online office hours.
Okay.
Yeah, I don't have one right now, but I may have one later.
Okay. So, Janessa, you come by the office, my online office hours or face-to-face office hours if you have questions, okay?
All right.
Okay. Then today what we're going to do is we're talking about two things, one that's on the exam and one that will be on exam 2. Complex fractions, section 8.5, will be on exam 1, and section 8.6 on solving rational equations is where exam 2 will begin. All right, so make sure that you note that on this opening screen here that one of these topics is the last topic for exam 1 and the other one is the first topic on exam 2. All right, so we're talking about complex fractions, and I know the name doesn't sound all that pleasant, but a complex fraction is simply a fraction that has fractions in it. That has fractions in the numerator or the denominator. Doesn't have to be both, but one or the other. Okay, so some examples. First of all, some simple examples would be something like this: 3/5 over, let's say, 9/25. Right, would be an example. Would be an example of a complex fraction. It's a fraction that has fractions in it. Now, this is a relatively simple example. Make sure that you remember that this fraction bar right here is really division, and that a fraction bar just means division. So 3/5 over 9/25 is really just another way of writing 3/5 divided by 9/25, like that. But those mean the same thing. And then you would just treat that as a typical division of fractions problem, and you have 3/5 times 25/9. And then this particular one that example that I made up does simplify. The 5 and the 25 divide out, leave you the 5 and a 1. And the 3 and the 9 divide out and leave you with a 1 and a 3. And so you end up with 5 over 3. And so, that looks pretty straightforward. The problem is not every complex fraction is written in quite that simple of a form. And so what we want to do is look at some complex fractions that are where you really can't just invert and multiply like I did in that problem, that you've got to go about it a different way. So an example would be a problem like this. If you had 3 plus 1 over x over 5 minus 1 over x, like that. This would be a little bit more involved of a complex fraction, and so this is not one, there's not just one fraction in the numerator and one fraction in the denominator. You have addition and subtraction in both the numerator and the denominator. And so when you have addition and subtraction, you can't just invert and multiply. So this problem, you can't just invert and multiply. See, because if you did this, 3 plus 1 over x divided by 5 minus 1 over x like this, see, it's not just a simple fraction that you're dividing by, and so you can't just invert right here. So you cannot just invert and multiply. And so what we want to do is talk about how you deal with this kind of complex fraction. This is the kind that you're going to encounter if you take more math classes beyond this one. Like if you go into college algebra or business calculus if you're a business major, if you're a science major and you go on and take trigonometry and the calculus sequence, you're going to have to be able to work with this kind of fraction. My Cal 1 students and my college algebra students both have already this semester had to deal with complex fractions a little bit as they've worked through some other types of problems. So it's just a skill that you're going to need if you're working with algebra, is how to simplify this. So simplifying means, by the way, simplifying a complex fraction means rewriting as a simple fraction that is reduced or simplified. And so a simple fraction simply means a fraction that doesn't have any fractions in the numerator and the denominator, right? And so that's what we want to do. So that's what I'm going to show you how to do with this kind of problem. And this is the example we're going to start with. This is 3 plus 1 over x and 5 over 5 minus 1 over x. So 3 plus 1 over x over 5 minus 1 over x. So first thing you want to do is you want to rewrite everything so that it kind of looks the same. So when I say kind of looks the same, I want to write all of the terms in here as fractions. So write everything so that it looks like it's a fraction, like that. That'll help you keep the arithmetic straight as you go through the problem and get rid of the denominators there. And then what you do is you identify the LCD of all the fractions, all the little fractions. And I'm going to put quotes around the word little there, all the little fractions. So that means all the little pieces inside that complex fraction, you want to identify the least common denominator there. So we're building the LCD just like we did addition and subtraction problems last week. And so you look at all the denominators there, and this problem's pretty straightforward. All the denominators, the only factor in any of the denominators is an x. And there's a 1 also in some of the denominators, so the 1 doesn't matter. So the LCD is just going to be x. All right, so that's your first step, is to identify the LCD of all the little fractions. The second step, and this is the critical one, is you're going to multiply, multiply the top and bottom of the complex fraction by the LCD over 1. You're going to multiply the top and the bottom of the complex fraction by the LCD over 1. So here's our complex fraction. I'm going to write it down again. And I'm trying to take a lot of room here in this problem. And so what I'm going to do is I'm going to put parentheses around the numerator and the denominator. And what I'm doing here is I'm going to multiply, and what does it say to do? It says multiply the top and the bottom by the LCD over 1. And so notice that's what I'm doing. I'm taking the LCD, putting it over 1, multiplying top and bottom by that. Now what am I really multiplying by? This, when we did this with addition and subtraction last week also, remember this fraction right here is really equal to 1. All right, x over 1 over x over 1 is really equal to 1. So I'm not changing the value of the fraction when I do this. So this is a legal thing to do in algebra. It's okay, it's always okay to multiply the top and the bottom by the same thing like that, because you're really just multiplying by the number 1. Right? This is really 1 right here, if you think about it, because you're taking a number and dividing it by itself. So what we do then is we use the distributive property. That's why I use those parentheses, was to emphasize that this is the distributive property. And you multiply this LCD over 1 through like this on both the top and the bottom. All right, so when you do that, multiplying fractions, just remember that just means multiplying the numerators and multiplying the denominators. So when I do that, I get 3x over 1 plus x over x over 5x over 1 minus x over x. Oh, and one thing I miswrote right in here, that's an x over x in there. Okay, there you go. And so you multiply it out. And then the third step is that you simplify each little fraction. All the little pieces there, you simplify. See, and they're all going to reduce now. 3x over 1 is really just 3x. And x over 1, or x over x rather, is 1. And then in the denominator, 5x over 1 is just 5x. And then x over x is 1. And boom, this is what we're trying to do. This is no longer a complex fraction. This is a simple fraction. And since it's a simple fraction, and in this case it's also simplified because there's nothing I can cancel out. There's nothing I can divide out because there's no common factors. Because I have addition and subtraction, I can't divide those x's out. And so it's simplified, and so that's my answer. That's the original complex fraction written in simplified form. So what I just put a box in right there is the same as this expression right there. Those are the same thing, but the second one is written as a simple fraction, and the first one is a complex fraction, right? And so that's what we're trying to do here. All right, so this problem, hopefully illustrates pretty well how we work this kind of problem out.
Okay, I have a question.
Go for it, Michelle.
What is the little fraction?
When I talk about the little fractions, I'm talking about all these little pieces. So like 3x over 1 is what I call one of the little fractions in there. And x over x is one of the little fractions. All these little pieces that are in here, that's what I'm talking about, that these are all the little fractions in the problem.
Okay.
Right? And so when I say simplify each of those little fractions, I'm talking about taking each one of those little tiny pieces and just simplifying it.
Okay.
And the same thing above when I say multiply top and bottom, or identify the LCD of all the little fractions, it's the same thing. At the very beginning of the problem, this was a little fraction, that's a little fraction, that's the little one, that's the little one right there. So all the little tiny pieces that you get that are separated by addition and subtraction symbols, those are the little fractions that I'm talking about. Does that make sense?
Yes.
All right, anybody else have a question?
Not right now.
Okay. All right, so we're going to work several more examples. So that's not it. So let's go to another example and work through this. So the next example, let's say we have 1 over x plus 2 over y over 3 over x minus 5 over y. All right, so now notice in this problem, all the little pieces are written out as fractions, so we're okay there. We don't have to rewrite it like I did the last problem. So now the question is to identify the least common denominator. That's our first step. So now the LCD in this problem, if you look at all the little tiny fractions in there, and again, that's all of these, everything I'm shading here is a little fraction in this problem. Right? And so the LCD, we write down all the different factors we see in any of the denominators. And in this case, there's two factors. There's an x and a y, both. And so that's our least common denominators, y. All right, all of them are raised to the first power, so you don't have to worry about You don't have to worry about raising anything in the LCD to a power at all. All right, so then what I do is I take parentheses, I put the numerator and the denominator in parentheses, and I'm going to multiply top and bottom by the LCD over 1. So LCD over 1, LCD over 1, right? That's what I've got right here, and that's what I've got right here. So since I'm multiplying the top and the bottom by the same thing, I'm really multiplying by 1, so I'm not changing the value of anything when I do this. And the way I'm multiplying this out is I'm using the distributive property. Right, so in both the top and the bottom, I'm using the distributive property. And now if you see how things cancel out when you do this, you could skip this next step, but I generally write this next step in just so that I can see how everything's getting, so I can keep all the factors straight as I go through the problem. So the first one, you have xy over 1 times 1 over x is xy over x. And then plus xy over 1 times 2 over y would be 2xy over y. And then that would be divided by, in the denominator I'd have 3xy over x, and then minus 5xy over y, like that. Right, and so I've multiplied everything out using the distributive property. I multiplied each of the little fractions by xy over 1. So, step 2 was multiply top and bottom by the LCD over 1. And then finally, step 3 is simplify each little fraction. All right, so when I simplify each of the little fractions, that means just canceling out the common factors, right? So I've got, x's cancel there, y's cancel there, x's cancel there, and y's cancel there. And so I just write down what I have left after I divide all those common factors out. So I get y plus 2x divided by 3y minus 5x, like that. And then at the end of the problem, you look at that and you what you've got left and say, well, first of all, is it a simple fraction? Have I gotten rid of all the little fractions in there? And I have. It's now just a simple fraction. Is it in simplified form? Are there any common factors? Can I do any factoring here? No. No common factors here at the end. No factoring to do. And so that's the answer. That's the simplified form. Right, so this is simplified at the end. And so that's my simple fraction. And again, remember, that was my original problem. This is the new fraction here at the end. And that second one is considered the simplified form because it's a simple fraction. All right, so hopefully that's looking okay. And these will get gradually a little bit more involved as we go through this. All right, so next problem. So please stop me if you've got a question. By the way, I'm now in your book. This is on page 947 of your book. And this is section 8.5's homework. And this is problem number 278. Problem 278. And you have 2 over r plus 2 over t divided by 1 over r squared minus 1 over t squared. Like that. All right. First thing, all the little fractions are written out as fractions, so that's good. The LCD in our problem here is, look, first of all, there's an r in the denominators and a t in the denominators. But in both cases, the r and the t are written somewhere as a square, and so you've got to include them as squares in the LCD. And so in this case, my LCD is r squared, t squared. remember, you have to use the largest power that you see in the original problem. So the r's, for example, there's an r to the first in there and an r to the second. That's why I have to put in r to the second in the LCD. And the same thing with the t's. All right, so what do I do now? The next thing I do is I multiply top and bottom. So I put parentheses, parentheses. I multiply top and bottom by the LCD over 1. So this is r squared t squared over 1 and r squared t squared over 1, like that. And remember what we're doing here is we are using the distributive property to multiply this out. So using the distributive property there. All right, so when I use the distributive property and multiply everything out, I'm not going to do any simplifying here. I'm just going to write out the fractions that I get. I get 2r squared t squared over r plus 2r squared t squared over t, all divided by r squared t squared over r squared minus r squared t squared over t squared. I want you to really be careful on that step. Make sure you write it all out. Be very careful about all the factors that you're writing. And at this point, what you should be able to do is simplify all the little fractions, right? That's the LCD guarantees that all these little fractions will all simplify, they'll all reduce. And so there'll always be stuff that you can cancel here, always. And so here there's an r that cancels in that fraction. And the next one, that second fraction in the numerator, the t cancels, and you're left with a t and a 1. In the denominator, r squared and r squared cancel, and a t squared and a t squared cancel. All right, so we write down at each little fraction what we have left, and in the numerator you have r t squared over 1. You know, technically, and I don't know if I've ever really mentioned that, but technically that's, and by the way, there's a 2 in there also. It's a 2r t squared. But you have technically 2r t squared over 1, but we just don't write the 1 in the denominator. So you have 2r t squared plus 2r squared t, all divided by, and then in the denominator, this is t squared minus r squared. All right, so that's a simple fraction. Now, in this particular problem, so I've gotten rid of the complex fraction. That's the first thing to do. And so that's good. In this particular problem, there is some factoring to do. And so you are not finished here. There is some factoring to do. And so you have to see if you can simplify in the numerator and the denominator. See if you can cancel out any common factors. So in the numerator, there's a common factor. Don't forget the GCF is always the first thing you do. So there's a GCF of 2RT. And when you take out a 2RT, you're left with a T in the first term plus, and in the second term, you're left with an R. In the denominator, that's the difference of two squares in the denominator. And so that's you're left with t plus r times t minus r. That's how it factors. A plus b times a minus b. And so notice in this problem there was a common factor that you're left with. The t plus 3's do divide out. The t plus r's do divide out. And so this did simplify, and you're left with 2rt over t minus r. Nothing else divides out because there's subtraction in the denominator, so I can't simplify anymore. And so that's my simplified expression right there. All right, Nancy, do you got a question?
I have a question.
Okay, Michelle, do you have a question?
Okay, so I see how it has t squared minus r squared. Why would we put a plus and a minus? As we going back to the things that you taught us, like, you know, when we was factoring before?
Yes, absolutely. And so this is a squared minus b squared, right? That's the difference of two squares. And so that factors, you know that factors a plus b times a minus b, and that's what I did right there. So what you said is exactly right. You're going back to all the stuff that we did earlier in the semester in Chapter 7 when we were talking about factoring polynomials. Yeah, you got to keep all. That was why we covered all that stuff, is so that you could simplify these kinds of fractions. So,
Gotcha.
Nancy, do you have a question? No. Sandra, do you have a question? Sounded like one of y'all had a question. Nothing yet? Okay. All right. Then let's move on to another problem. All right. So next question that I want to look at. So, you know, the author, again, kind of goes a little bit nuts with these problems, to be honest with you, but that's okay. Let's look at problem number 288. This one's actually not too bad. It just looks different. You have n, that's an n, over n minus 2 in the numerator, and then in the denominator you have 3 plus 5 over n minus 2. Like that. All right, so the first thing I would do in this problem is I would make all the little fractions kind of look like fractions, right? So now the numerator, this is n over n minus 2, just leave that alone. In the denominator, that 3, I'd like to write that as 3 over 1. And then this is 5 over n minus 2. That way, everything's written as a fraction, like that. All right, so now you build the LCD. Now, the only factors you see in any of the denominators are n minus 2. And just before I pause here, again, are there any questions anybody has? I feel like maybe that there's a question, but I'm not hearing anything. Anybody have any questions? Nancy, I don't know. I think maybe you have a question, but okay. So Nancy's asking about the last problem, and so I think she was just putting in a question. I didn't see it until after I started in this one. She talking about the denominator. So we want to go back for a second and talk about the denominator. You know, you're taking. So Nancy, you've got this little fraction right in here, and all you're doing is taking that little fraction that I've highlighted in pink. And if you've got a common factor in there, in that little fraction, you cancel it out. So I cancel out the r squares, but what am I left with when I cancel out the r squares? I'm left with t squared over 1, right? And in the second fraction, I've got r squared, t squared over t squared, and I cancel out a t squared out of the top and the bottom of that little fraction, and that leaves me with an r squared right there. And so that's what I'm doing when I simplify there. Okay, so I think you're okay. All right. So all right, that's good. I don't have a problem answering questions. Absolutely not at all. All right, so let's go back to this problem. I've got all the little fractions written out now as fractions, and so the only factor I see in any of the denominators is n minus 2. And so n minus 2 is my LCD. It's raised to the first power. So, and so now I put parentheses around the numerator and the denominator. Now notice the numerator doesn't have any addition or subtraction. It's just a single fraction. That's okay. This actually makes the problem slightly easier in the numerator. So I multiply by n minus 2 over 1 and n minus 2 over 1. Now notice in the numerator, it's not the distributive property anymore in the numerator because there's no addition or subtraction in the numerator. It's just a single fraction. So that's just multiply those two fractions together. So you have n times n minus 2 in the numerator, and in the denominator, n minus 2 times 1 is n minus 2. the denominator, I do have an addition there, and so this is the distributive property to multiply this out. All right, so when I do that, let's see, what do I, in the denominator, then in the first fraction, I get 3 times n minus 2 over 1, and then plus, and then 5 times n minus 2 over n minus 2. Right, remember, you're multiplying both fractions by n minus 2 over 1. All right, and so now this is just like the last problem we were just talking about when I was answering Nancy's question. We go through and we divide out all the common factors. So the n minus 2's divide out in the numerator right there. And that leaves me in the numerator with just n over 1, or just n. Right? That technically that's n over 1 when I divide out, but I don't write it as n over 1, I just write it as n. In the denominator, I've got that 3 times n minus 2 over 1, but that's just over 1, so there's nothing to divide out there. And so that's just 3 times n minus 2. And then in the second fraction, the n minus 2's divide out, and I'm left with a 5. Like that.
Why wouldn't we just multiply the 3 by the n minus 2? Why do we keep it on the outside?
I'm going to do that. And I could have done that, Michelle, on that step. I just chose to not do a second part to that, but you're absolutely right. I would multiply that out. And so this would be 3n minus 6 right there, plus 5. And then you know, there are some like terms in the denominator, so that's just 3n minus 1, like that. And the negative 6 and the 5 add together. And so that's the simplified form. So yeah, you're absolutely right. You would want to multiply that out. So. All right, anybody have any questions about that one? Okay, so I think we're okay. Next problem. This one is not in your book. So let's say we have this fraction, this complex fraction. Let's say we have, I have to make sure I get this right here. So I have 1 minus 3 over x minus 4 over x squared, all divided by, and let's see, the next one I want to be 1 minus 16 over x squared, like that. Okay. So now there's 3 fractions in the numerator. And again, you might want to write everything so that it's a fraction. So that 1 that's in the first term, write it as 1 over 1. That way, at least it looks like a fraction, like the other ones do. It's nice to make everything look kind of the same in a complex fraction like this. And do the same thing in the denominator. So that's a 1 over 1 right there also. All right, so the LCD in this problem. You know, I look at all the denominators, and the only factor I see in any of the denominators is an x. All right, but the x is raised in a couple of fractions to the second power, and so I have to include it to the second power in the LCD. And so that's my LCD. It's just x squared. So now I'm going to put parentheses around the numerator and the denominator, and I'm going to multiply by x squared over 1 and x squared over 1, like that. And because there's subtraction in both the numerator and the denominator, these are distributive property problems. And so you're multiplying like this. Right? And in the denominator, multiplying like this. Right? You want to multiply every little fraction by x squared over 1. So when I do that, I get x squared over 1 times 1 over 1 is x squared over 1, and then minus 3x squared over x, and then minus 4x squared over x squared. And in the denominator, I get x squared over 1 minus 16x squared over x squared. So I multiplied every little fraction there by x squared over 1. So when you do that, again, what you're going to do next is you're going to simplify each of the little fractions. So x squared over 1 is just x squared. 3x squared over x is 3x. One of the x's cancels. And then 4x squared over x squared is 4. And then in the denominator, you get x squared minus, and then the x squares cancel on that last fraction. You're left with 16. And then that, okay, so we've got, that's a simple fraction, right? All the complex fractions, the complex fraction is no longer there. It's now a simple fraction. And, but then there is some factoring to do. And so you have to factor in the numerator and the denominator. In this case, the denominator is the difference of two squares. It's a plus b times a minus b. So this is x plus 4 times x minus 4. And in the numerator, x squared minus 3x minus 4 is an example of an easy trinomial. So we're just looking for factors of negative 4 that add to give negative 3. And that's negative 4 and 1. So it factors x minus 4 times x plus 1. And so, in fact, this is something that where I do get a common factor. The x minus 4s are common. And I cancel those out or divide them out. And then I'm left with x plus 1 over x plus 4, like that. And that's my simplified answer. So notice we simplified this complex fraction quite a bit, because that's what we started with. And that's equivalent to that last expression there. And so obviously much simpler in that last form like that. Okay, so that's a good look at complex fractions. And so I'll save homework on that until the end as far as textbook homework to look at. But all right, so we're doing good. So we are now moving on to section 8.6. And this is on equations that involve rational expressions. Remember, the whole chapter is about rational expressions, and these complex fractions are really just rational expressions written in kind of a nasty form. So rational equations, we're now looking at equations where there are rational expressions or fractions in the equation and how you go about solving those. And so first thing I'm going to do is look at a relatively simple kind of rational equation that looks like this. This is x plus 5 over x minus 4 equals 3/5, let's say. Like that. All right, this is an example of a rational equation. Now notice it has an equal sign in it. And that's one thing I want to point out. But there's an equal sign. And if you look at all the other problems we've done today, none of these, as we go through this, none of these have equal signs, right? There's no equal sign anywhere in any of those problems as I go through the notes. Even if if you go back to the last lecture, this is, bear with me here. The last lecture was last week, but at the end of that lecture, we were talking about addition and subtraction of fractions, and notice there were and all these problems, no equal signs anywhere, right? Like this was problem 200 that we looked at back in the last chapter or the last section, and it was just an addition problem. There was no equal sign there at all, right? Same thing here, just a subtraction problem, no equal sign anywhere. So those are just addition and subtraction problems. But what are we talking about? We're talking about problems that have equal signs in them. And so this is an equation right here. It's not an addition or subtraction problem. This is an equation. And what are we trying to do when we look at an equation? We're trying to solve that equation. Right? We're trying to solve it. And so what are we trying, when we solve it, what does that mean? We're trying to find an x value that makes it a true statement. Okay, so how do you do that with a rational equation like this? And the goal here is very simple when you have a rational equation. When you have a rational equation, when you have an equation that has fractions in it like this, you are trying to get rid of the fractions. That's the simple goal. Get rid of the fractions. And so the question is, how do you do that? How do you get rid of the fractions? Now, this particular problem that I just wrote, x plus 5 over x minus 4 equals 3/5, is an example of a rational equation, but it is also called a proportion. And the reason why this is called a proportion, so it's a special kind of rational equation. It's called a proportion because it is simply a fraction equals a fraction. There's not like an addition or subtraction problem on both sides. It's just one single fraction on one side of the equation equals one single fraction on the other side of the equation. And when you have a fraction equals a fraction, that's called a proportion. So it's a special kind of rational equation. Don't think it's different in some way. I mean, it's different in the way it's written, but it's just a special kind of rational equation is all it is. And so you have something like this: a over b equals c over d. And the thing is, these are easier to solve when it's written in this form, because all you really have to do, what has to be true here, is that the cross products have to be equal to each other in order for that to be true. In other words, what do? You just cross multiply. And you can get rid of the fraction super easy by just cross multiplying. This doesn't work if it's not a proportion, but if it is a proportion, you want to be able to use this simple technique to solve the problem. So here's our problem right here. All you literally got to do is cross multiply. So you take x minus 4 and you multiply it by 3. And then you take x plus 5 and you multiply it by 5, right? You literally cross multiply in this case. And when you do that, you get something that doesn't have any fractions in it. Right? There's no fractions in this equation right here. And so it's super easy when you have a proportion to get rid of the fractions. You just cross multiply. So when you have a proportion, easy to solve. Now, so we solve this equation. This is a linear equation. There's all the x's are raised to the first power. And so you just multiply everything out, get all the x's on one side, get all the constants on the other side. Right? So I subtract 3x from both sides of the equation. Right? Subtract 3x from both sides. I get 2x plus 25 equals negative 12. And then I subtract 25 from both sides. And I get 2x equals negative 37. And then finally divide by 2. And I get x equals negative 37 halves. And so negative 37 halves is going to be my solution here to this equation. All right, so that, always be kind of looking for whether you have a proportion or not. And if you do, then you really have an easier way to solve the problem. All right, so let's look at another example of a proportion before we leave that behind. So let's just look at one more example. Let's say I've got b over b minus 16 equals 11 over 9. Like that. All right, so b over b minus 16 equals 11 over 9. Definitely a proportion, definitely a fraction equals a fraction. So you cross multiply to solve this equation. And so when you cross multiply, you're multiplying there, you're multiplying there. Right, so you get 9b equals 11 times b minus 16, like that. And what are you left with? You're left with an equation that has no fractions left in it. And so there's no fractions left here, and that's what you're trying to do, right? That's your goal. And so then you solve that equation. So you get 9b equals 11b minus, let's see, 11 times 16 is, I believe, 176. And again, not something where I'm going to give you problems where the numbers are going to be that big. I'm not going to worry about making the arithmetic difficult on these kinds of problems. And then solve this one for b. So you subtract 11b from both sides. And so that gives you negative 2b equals negative 176. And then you divide by negative 2. And when you divide by both sides by negative 2, you get b is equal to 88, I believe, and it's positive. So 88 is our solution in this problem. Now, one thing that will happen here sometimes is that when you solve a rational equation, this is something you do have to be careful about. Let's say, who knows what you have over here, but you solve this rational equation and you get b equals 16 as a solution. Now remember, when you get a solution, so this is pretending, by the way, right here. Okay, so we're pretending that you've got this equation, b over b minus 16 equals some fraction. Who knows what the other fraction is? And we don't really care over here. But when I cross multiply and solve, I end up with b equals 16 as the solution. This is going to actually happen sometimes, and so you have to be aware of this. When you try to check b equals 16, try to check b equals 16, notice you get 16 over 16 minus 16 equals, who knows what this is over here, and so you get 16 over 0. And 16 over 0, I'm not going to ask you what that's equal to because I'm afraid what you're going to tell me, but 16 over 0 is undefined, right? You can't divide by 0. So this is an undefined expression. You remember, and you cannot divide by 0, right? It's not possible to do. Sometimes when you solve a rational equation like this, you get a number that gives you division by 0. So when that happens, what do you do? And that is when this happens, you throw that solution out. And so in this case, 16 would get thrown out, and if that was the only solution, you'd have the empty set as a solution set for this. In other words, there'd be no solution to the equation. This is going to happen. Now, the only thing you have to worry about, since you're talking about division by 0, the only thing you have to worry about are the denominators, okay? And what makes the denominator of a fraction equal to 0? What value of the variable makes the denominator equal to 0? And so this is something that you've got to be aware of and be careful about. All right, so let me show you a problem, and let's talk about this, how you can tell by looking at it what numbers to throw out. So this is, I'm on section 8.6 in your book, by the way, and this is page 963 in your book. Yeah, page 963 in your book. And the problem I'm looking at is number 320. Now this is not a proportion, first of all. So this problem, you have 5 over y minus 9 plus 1 over y plus 9 equals 18 over y squared minus 81. Okay, so this is a rational equation, just like we've been talking about, but it's not a proportion. So and the reason why is because it's not just a single fraction on the left side of the equation. So this is not a proportion. So cross multiplying does not work. right? You can't just cross multiply to get rid of the fractions here. So I'm going to have to show you how to do that, how you get rid of the fractions in this problem. But before we do that, let's talk about, notice that the last denominator factors. So factor all denominators. So factor all denominators in these kinds of problems. And in that last denominator, the y squared minus 81 factors as y plus 9 times y minus 9. Like that. Now, before you try to solve the equation, are there any restricted y values? Are there any y values that you can't get in this problem? Are there any restricted y values? And so what does that mean? So are there y values that, if you tried to check them, gave you 0 in the denominator? What values for y would make a denominator equal to 0? And it's actually pretty easy to look at, because what about y minus 9? What makes y minus 9 equal to 0? Well, that would be y equals 9. Right? If you put 9 in there for y, you get 9 minus 9, which is 0. And y plus 9, the restricted value would be y equals negative 9. And so there are restricted values here. Y cannot be 9, put a not equal to there. Y cannot be equal to negative 9. So those are my restrictions in this problem. So that means if I come up and solve this equation and I get either 9 or negative 9 as a solution, I must throw it away. All right, so now, how do you get rid of the fractions? Well, you first thing you do, this is it's very similar to complex fractions in one way. You find the LCD, and what you're going to do is you're going to multiply the left and the right side of the equation. So this is the left side of the equation. This is the right side of the equation right here. And what you're going to do is you're going to multiply the left and right side by the LCD over 1. Now I'm going to come back and write this problem again, and we're going to work it on the next page where we have a little bit more room here. But in general, if you have an equation that's not a proportion, this is how you're going to, that's a rational equation, this is how you're going to solve it. Is you're going to take the left side of the equation and multiply it by the LCD over 1, and you're going to take the right side of the equation and multiply it by the LCD over 1. You know, notice how that's different from what we did with complex fractions. With complex fractions, and we were simplifying complex fractions. We weren't solving, we were simplifying. So this is a solving process on this one. Here we're simplifying. And what did we do when we simplified a complex fraction? We took this ugly fraction that we had, and what did we do? We multiplied the top by the LCD over 1 and the bottom by the LCD over 1. So, you know, really different process because it's a different kind of problem, right? For complex fractions, we multiplied the top by the LCD over 1 and the bottom by LCD over 1. We had to do the same thing to the top as we did the bottom. That was a simplifying problem. That goes with simplifying right here. But with solving, you multiply left and right side by the same thing. You don't multiply top and bottom by the same thing. You multiply left and right side of the equal sign by the same thing. So it's a different kind of problem. You have to be careful about what kind of problem you're actually working with. Okay? All right. So let's look at our problem now. So you've got 5 over y plus 9 plus 1 over y. No, that was, I'm sorry. Apologize. That was y minus 9 right there. And then plus 1 over y plus 9 equals 18 over y plus 9 times y minus 9. Well, what are the only factors in any of the denominators are y plus 9 and y minus 9. So I put brackets around the left side and the right side, and I'm going to multiply the left and right side by the LCD, which is y minus 9 times y plus 9 over 1, like this. And you multiply both sides by that, like that. Now, on the left side of the equation, you have the distributive property, right? Because there's an addition problem there. So you'd have to multiply the y minus 9 times y plus 9 by both of those fractions. On the other side, there's not a distributive property problem because there's no addition or subtraction over there. So if you want to, you can multiply this out. This gets kind of yucky here to write all this out, but you could multiply this out and write it as 5 times y minus 9 times y plus 9 over y minus 9 plus y minus 9 times y plus 9 over y plus 9 equals 18 times y minus 9 times y plus 9 over y plus 9 times y minus 9. Now, a lot of times I'll try to write that out. I'll just try to do the simplifying right away there, but you could write that step out like that. And then what do? You go through. Remember, the goal is you're trying to get rid of all the fractions in there. And so what happens? The y minus 9s divide out there. The y plus 9s divide out in that fraction. And both the y minus 9s and the y plus 9s divide out in the last one. And when you write down what you have left, sure enough, all you've got left here are things without fractions. All the denominators are now gone. And this is what you're left with at the end when you've divided everything out. So for the most part, not for the most part, but you've divided everything out. This is a linear equation right here. And so now you're going to solve this linear equation. Right, all the y's are to the first power. So you have 5y plus 45 plus y minus 9 equals 18. Collect like terms, you get 6y plus 36 equals 18. You subtract 36 and you get 6y equals negative 18. And then you finally divide by 6 and you get y equals negative 3. Negative 3 was not one of my restricted values. Remember that the restrictions we found in this problem were that y could not be 9 and y could not be negative 9. And so negative 3 is not a restricted value, and so that's my solution right here is negative 3. All right, so if the equation you've got is not a proportion, then what you're trying to do is multiply left and right side by the LCD over 1, and then solve the equation. You're also trying to look at the restrictions in the problem, see what restricted values there are, if any. All right, let's go on to the next problem. All right, so and this will probably be my last problem of the day here. This is number 336. And number 336, same page, so that's page 963 in your textbook. This is m over m plus 5 equals 50 over m squared minus 25 plus 6. And that 6 at the end, I'd want to write that as 6 over 1, which I'll do in the next step. Now remember the first step, factor everything. Factor all denominators. You definitely want to do that. So I have m over m plus 5, no factoring there, equals, and then this would be 50 over m squared minus 25 is the difference of two squares. It factors m plus 5 times m minus 5. And then that 6 I'd write as 6 over 1. Like that. And there's my fractions, all written with factor denominators. Next thing to do, find all restrictions. Right? Are there any values that m cannot be equal to, right? And you're looking at the denominators here, remember. And so from m plus 5, we get that you get m equals, m can't be negative 5 from that one, right? If you put negative 5 in there for m, you'd get negative 5 plus 5, which would be 0. And then m minus 5 right here gives you another restriction of m can't be 5 either. And so, because 5 minus 5 would be 0. And so those are my two restrictions here. M can't be negative 5, and m cannot be positive 5. So if we get either of those, we've got to throw them out of the solution set. Next step, so factor all denominators. Find all restrictions. Next step, multiply left side and right side by the LCD over 1. So here's the left side, here's the right side, L and R. And what are you going to do? You're going to multiply LCD over 1 on that side and LCD over 1 on that side, right? That's your third step for this kind of problem. So the only factors in the denominators here are m plus 5 and m plus 5 and m minus 5. So the LCD here is going to have both of those factors. And so that's what I'm multiplying left and right side by. Now it's getting a little messy there, so I'm going to write that down again right here. And I'm going to put brackets around the left and right side. And I'm multiplying left and right side by the LCD over 1. So there and over here also. Oops. All right, and so when you do that, on the right side of the equation, you do have the distributive property right here, because you have an addition problem there, so you got to multiply that by both of them. On the left side, there is no distributive property there because there's no addition or subtraction. So this is just m times m plus 5 times m minus 5 over m plus 5 equals, and on this side of the equation, you have 50 times m plus 5 times m minus 5 over m plus 5 times m minus 5 plus 6 times m plus 5 times m minus 5 over 1. Now, that's a messy step right there. And if you can, and then you go through and you cancel out common factors. So there's m plus 5's divide out on that side of the equation. And on the right side, m plus 5's divide out and m minus 5's divide out right there. And then nothing divides out in that last fraction. And so we're left with m times m minus 5 on the left side of the equation equals 50 plus 6 times m plus 5 times m minus 5 on the right side of the equation. Right, all the fractions are gone. All the fractions are gone there, but you're left with kind of a messy equation. And when you multiply this stuff out, you start seeing that you're going to get m squares in here. And so this is going to be a quadratic equation when you multiply this out. And by the way, that's 6 times m plus 5 times m minus 5. What I would do is I would leave the 6 there and take m plus 5 and m minus 5 and multiply those together, which it's just a plus b times a minus b. So it's m squared minus 25. So this problem's going to go on for a while here. And then you've got 6m squared minus 6 times 25 is 150, like that. So this ends up being a quadratic equation that you've got to solve. So remember, since it's quadratic, I'm going to kind of squeeze this in here at the end, you have to set equal to 0. And so, I'm going to have to kind of collect like terms and get this thing set equal to 0. Now, let's see. I've got a little bit with like terms I can do here. I'm going to kind of continue it right here. I've got m squared minus 5m equals, and on the other side of the equation, I have 6n squared minus 100 because I have a 50 minus a 150. So I have minus 100 right here. And because of where the n squares are, I'm going to subtract n squared from both sides of the equation. That's an m there. So I'm going to subtract m squared.
Okay, I have a question because it looks like it's a m. It looked like 6m squared, but over here it looks like you saying n.
And I know I think I corrected it.
They look like the same.
I think I corrected it, but they are, yeah. For some reason, started writing m's instead of m's. Yeah. So, but I think I corrected it, Michelle. I'm looking at it, but I think m squared minus 5m. I think I got it all. So, so I subtract m squared from both sides, and so you have negative 5m equals 5m squared minus 100, and then add 5m to both sides. And when you do that, you get 0 on the left side of the equation. It doesn't matter whether you get 0 on the left side or the right side. So I got it on the left side so that the m squared would be positive. And you have 5m squared plus 5m minus 100. Yuck. All right, so I'm gonna continue that problem on the next page, but so going back over this again, before I flip the screen here, the first thing I did is I factored any denominator that had factoring in it. So that's the first step. And then the second step is to find all the restrictions. In other words, look at the denominators and see if any value of the variable makes the denominators equal to 0. The next step after that is to write down the LCD. And so I wrote down the LCD, which is all the factors that you see in the denominators there. And then you take the LCD over 1 and you multiply the left and the right side by the LCD over 1. And when you do that, you should end up with an equation, when all said and done, you should end up with an equation right here that has no fractions in it. And that equation has no fractions. Now, what you have to do there, once you get to that equation, is decide whether it's quadratic or linear. And, if it's linear, just get all the variables on one side and solve it. If it's quadratic, you have to set it equal to 0, which is what I did there. All right, so now carrying over onto the next page, you have 0 equals 5m squared plus 5m, and that was minus 100. Let me go back, check that. Yeah, that was the right equation. Okay. And so now to solve this, first thing I do is take out a common factor of 5. And then I would go through and I would factor, and what you're left with is an easy trinomial, luckily. And so this is m plus 5 times m minus 4, like so. And so you set each factor equal to 0. The 5, remember that constant factor at the beginning, you throw it away in this case. If it's a constant factor, it does not give you a solution at all. And so you end up with m equals negative 5 and m equals 4. But now remember that the restrictions for this problem from the previous pages, from the previous screen, restriction from the previous screen was that m could not be negative 5 and m could not be positive 5. So notice that I've got a restriction right here. When I solved this equation, I got one of the restrictions. So what do you do with negative 5? You throw it out, right? So our solution set we would think is negative 5 and 4, But what do? We throw -5 out. Right? And so our actual solution set in this case is just 4. Why did we throw out -5? Because it was a restriction. If we tried to check it, we would get division by 0 in this problem. All right. All right. So that's the last example I think I'm going to work today. Your textbook homework. Sometimes I have been noting that I've been forgetting to write the textbook homework down. And I've tried to add it in later. And remember, the textbook homework is not something I ever pick up. So it's something strictly for your own enjoyment. And if it's not for your own enjoyment, at the very least, it's for you to practice, what you need to practice, the skills that you need to practice for the test. So that's why I think it's a good idea to get in the habit of working some of this. So on section 8.5 on complex fractions, page 947, problems 263 through probably 283 odd. That's not that very many problems right there. And then on page 963, this is section 8.6, problems 303 through, in this case, problems, I would say, up through 337. Those would all be good practice problems. So, all right. So, does anybody have any questions that they want to ask about, or anything going into the rest of this week? Anything I've just covered that you need to ask about before we leave? Thank you, Jose. Anybody else have any questions at all?
No question at the moment.
Okay. So remember that I will be online again from 1 to 2 this afternoon, and then I will be on campus tomorrow and on the next day. So please, I'd love to see you come by the office for help tomorrow or the next day, and actually meet you in person. One thing I did want to ask about, I've been sending emails out through WebAssign, and I've been trying to send out weekly updates. So I sent out a weekly update yesterday. Are all of you guys getting those updates through email?
I have.
Okay.
Yes.
Okay. All right. So most of you, okay, I'm hearing from most of you that you're getting them. Good, good. So I'm going to continue to be doing that. Probably every Sunday or Monday. In your class, I think it'll be Sunday or Monday of each week. I'll send out a weekly update about what's going on in the class for the next week or so, to kind of keep everybody on track as far as where we're headed and everything. So, okay. So you guys have a great rest of your week. Study hard for the test. And please let me know if you have any questions, okay? All right, everybody have a great day. Thank you.
You too.
Thanks.
You too.
Thank you.